Here is a very interesting thinking problem on domain and range. Question 33. Write domain and range of f of x equals to 1 over square root of 1 over 2 times square root of 25 minus x minus 3 whole square minus 2. Well, my student shared this problem with me today, and I thought it important to share it with all other students. Now, to find domain of this function, we should find the restrictions. And what are the restrictions? We know one thing, that the denominator cannot be 0. That gives us some restrictions. And second set of restrictions is that within square root we cannot have negative things, right? So square root should be non-negative. So these are two sets of restrictions. So combinations of these restrictions will give us domain. And then we will see how to find the range. As far as range is concerned, we know that this is like 1 over something. So horizontal asymptote is y equals to 0, the x-axis. So y cannot be 0, but then what can y be? So those are the questions which will be answered soon. So let's look into first the easier part, which is domain, right? So domain restriction, let's go back to this. 25 minus x minus 3 whole square, square root. So within square root, this should not be negative, correct? So this has to be greater than 0 or equal to 0. Perfect? So we'll solve for that first. We say 25 minus x minus 3 whole square. This part should be greater than equal to 0, correct? Otherwise, within square root, this function is not permitted. So when we solve it, we can say we'll take this side, so 25 is greater than equal to x minus 3 whole square, correct? Now we'll do square root. When do square root of 25, we get plus, and when do minus, we have to change the sign. So that means we can write this as a double inequality, which is x minus 3 has to be less than equal to 5, which is plus square root of 25, and has to be greater than equal to minus 5, correct? Now we'll add 3 both sides. We say 5 plus 3 is greater than equal to x, which is greater than equal to minus 5 plus 3. So we get x is within minus 5 plus 3 is minus 2, and here 5 plus 3 is 8. So x is within this region, correct? Now, does that make sense to you? Let's see. So we can see it in a different way also. Let's say, let's try to sketch this function approximately, okay? Now, we are trying to sketch now the square root of 25 minus x minus 3 whole square, correct? The function, this within square root. Do you know what this is? This is equation of a semicircle, positive half of the circle, correct? Okay. Now, okay, I'm just thinking, should I tell you the details? Okay, let's get into that detail also. But that's beyond, this point which we are trying to prove. I'm just trying to show now what is this function, square root of this, right? I hope you remember this circle formula, which is x square plus y square equals to r square, right? Now here, what is y square equals to? We say y square is equals to r square minus x square, and y is equals to square root of r square minus x square with plus and minus, right? If I write plus only and not the minus, then it's upper half. Well, if I write minus, the whole circle. X square plus y square equals to r square is actually a circle, correct? This is a circle whose center is at 0, 0, right? And radius is r, correct? So this is a circle whose center is at 0, 0 and radius is r. Now when you do, you can write this as square root of plus minus. And when we say like this one, we are only considering the positive half. That means we are only interested in the top part of the circle. Do you understand? With the radius r, correct? Here the r is 5 square, 25. Do you understand? And x point is shifted 3 units to the right. Do you understand? So basically, we have a circle like this here, kind of. Let me make a small circle here, where the center is shifted to 3. Do you see that? And the radius is 5. That is how our circle is. So this center is at 3 and radius is 5. That means 3 plus 5 is 8, right? And 3 minus 5 is minus 2. Do you see this? X is between 8 and minus 2. Do you see between 8 and minus 2, correct? So that is exactly what we got basically from this function, which is the equation of a semicircle, correct? So that is our one part of domain, correct? The next part of domain is that the whole denominator cannot be 0. So let's solve for that also. That is to say that 2 times square root of 25 minus x minus 3 whole square within square root minus 2 should not be equal to 0. Is that okay? So because it is in the denominator, 1 over 0 is not defined. So if you solve this, we get 2 times square root of 25 minus x minus 3 whole square root is should not be equal to 2, and then we'll divide by 2. We get 25 minus x minus 3 whole square should not be equal to 2 divided by 2, that is 1. And now we can square both sides and say 25 minus x minus 3 whole square is not equal to 1 square, right? And to solve this, we can say 25 is not equal to x minus 3 whole square. And now we can square root it, right? So when we square root 25, we have to write plus and minus is not equal to x minus 3, correct? So x is not equal to, we'll take 3 this side, 3 plus and minus. Oh, we forgot to do minus 1 this side, sorry. So when we do minus 1, let me bring minus 1 here. So this is 25 minus 1, this is 25 minus 1 within square root, correct? One I forgot here, right? So 25 minus 1 is 24, we'll say square root of 24. Well, that was in good time. So we get x is not equal to 3 plus minus square root of 24, correct? Now if I use calculator to find approximate value of this, I say, okay, square root of 24, let me check first. 24 is equal to 2 square root 6, approximately 4.89. So when I do plus 3, I got 7.89, which is 7.9. So I say that approximately I can write this as, now let me write this. When I do plus, I got 7.89, which I can write approximately 7.9, okay. And when I do minus, so I do 3 minus square root of 24 equals to minus 1.89, so I get minus 1.89. So these are the two values. 7.9 will be, let us say, very close to 8, let's say here, and minus 1.89 is here. So at these points, my denominator is 0. So these points are also not permitted as a part of my domain, correct? So that is what I've got so far. So I can say, well, my domain is, now I can write here domain is x belongs to real numbers, so that x is between minus 2 and 8. So let me write minus 2. X is between minus 2 and 8, both included, and x is not equal to 7.9 and minus 1.9 approximately. Okay, so that's my domain. Now how to find the range? To find range, we need to do reciprocal of this, correct? Now we can actually graphically see what the answer could be. Now within this period, we know maximum is at 3, and this point at 3 is 5, correct? Now let's go back to our function f of x denominator part, which is square root of 25 minus x minus 3 whole square, which is a semicircle. I need to stretch it by a factor of 2 and move it 2 units down. So if I stretch this by a factor of 2, then what do I get? This point 5 comes at 10, right? And all these points, but 0 times 2 will be 0. So what I get is kind of a shape like this, kind of a parabola. Is that okay? So this is 2 times this. And now what I need to do is to bring it down by 2 units, right? We are doing the denominator part alone. We'll do reciprocal of this next half. Minus. So we'll bring it down by 2 units. So at present my peak is at 10, right? So I bring it down by 2 units. So I come here, every point will come down, let's say by 2 units, and this point comes here, and this point comes here. So this will be at minus 2, correct? This will be at minus 2. And this will be at, this is 10, correct? And 10 minus 2 is 8 for us. So 8 is this point. So we'll bring it down by 2 units, so it becomes kind of like this. Do you see that? That's my function f of x 1 over. So let's call this the whole denominator. Let me call this as 1 over g of x. So that is g of x which I have drawn, correct? Now what I need to do is to draw reciprocal of this to get the range. Now as you can see from the graph, if I do reciprocal of this, I get vertical asymptotes at these points, correct? So 1 over g of x is not defined at these points. And what are these points? These are the points. 3 plus minus square root of 24 are these points. Do you understand? Because reciprocal will give me a vertical asymptote. Now, here we have 8. So what is the lowest point on this side, on the positive half? Positive half will be 1 over 8. Let's say this is 1 over 8. And reciprocal of positive is always positive, correct? And as we approach minus 1.9 on this side, we'll approach infinity. So this half of a graph will be kind of like this. Is that okay? Approaching this with a minimum here. So we can say as far as range is concerned. So let me use a separate ink. And let me make a block here so that I can write clearly in one block, which is very small for me, range. So range is y belongs to real numbers where I'm trying to find the conditions. Where first part is, this is reciprocal of 8. So where y is greater than equal to 1 over 8. This is first part which we got, correct? And in the lower half, the lowest point is minus 2, which is this point. Reciprocal of minus 2 will be minus half, and negative reciprocal is always negative. So this part will be like 1 over x curve like this. So we'll say y is less than equal to minus 1 over 2. So that becomes our range.